Welcome back to the series 1000 Must Solve Problems for NEET Physics. A body is suspended from the ceiling of a room with the help of a chain. If m1 and m2 are the masses of the body and the chain, then the force with which the ceiling pulls the chain is. There is a ceiling here. Okay, one chain is there. One body of mass m is hung here. Okay, m1 and m2 are the masses of the body and the chain. Okay, m1 is the mass of the body, m2 is the mass of the chain. So what is the tension at this point here? At this point the tension is, okay, this point has to withstand the weight of m1 and m2. So therefore net downward force will be equal to m1 plus m2 into g, because this mass is being attracted with this force equal to m1g. This mass also being attracted downwards with the force m2g. So m1 plus m2g will be m1 plus m2 into g. So the force with which the ceiling pulls the chain is m1 plus m2 into g. Next question. 3 equal weights A, B and C of mass 2 kg are hanging on a string passing over a fixed frictionless pulley as shown in the figure. The tension in the string connecting the weights B and C is here. Okay, in this portion of the string, what is the tension? The equation of tension is easy to remember. Tension is equal to, okay, so this is being pulled from two directions. So 2 should come here. G should be there in the numerator. Total mass should be there in the denominator. So MA plus MB plus MC. Total mass should be in the denominator. Then if you observe here, okay, see this, if mass of C becomes 0, then there is no tension in this string. Okay, if mass of C becomes 0, then there is no tension. So therefore mass of C, MC should come in the numerator. And let us suppose that mass of A is 0. If mass of A is 0, then this system will be in free fall. Then there will not be any tension in this string. That means mass of A also should come in the numerator. This is how you can remember this diagram. Now you substitute T is equal to 2 into mass of C is 2, mass of A is 2, acceleration due to gravity is 9.8 divided by, so 2 plus 2 plus 2. So what happens? So 2 into 2 into 2 divided by 6 into 9.8. So 2 goes 3 times. Okay, so tension will be equal to 2 into 2 is 4, 4 into 9.8 divided by 3. Okay, now see, 4 into 10 is 40, 4 into 9.8 is 39. It will be 39 by 3. 39 by 3 is equal to 13 Newton. So the tension in this portion of the string is 13 Newton. Option B is correct. Next question, question number 57. Two masses of 4 kg and 5 kg are connected by a string passing through a frictionless pulley and are kept on a frictionless table. Okay, this table is frictionless. The acceleration of 5 kg mass. So now this question is very simple. Acceleration is equal to unbalanced force. Acceleration equal to unbalanced force, okay, divided by total mass. The weight of 4 kg mass and the normal reaction are getting balanced. So that is balanced force. Here weight of 5 kg mass is not getting balanced. So what is unbalanced force? Unbalanced force is equal to weight of 5 kg mass, okay, that mg, divided by total mass is 4 plus 5. So m1 plus m2. So acceleration is equal to 5 into g, 50, okay, divided by m1 plus m2 means 5 plus 4, total mass, that is 9. So 50 by 9. 45 by 9 is 5. Okay, 50 by 9 is around 5.5. So therefore 5.44 approximately it is equal to 5.44 meter per second square. So option B is correct. Question number 58. A mass m rests on a horizontal surface. The coefficient of friction between the mass and the surface is mu s. If the mass is pulled by a force F as shown in the figure, the limiting friction between the mass and the surface is. The limiting friction between the mass and the surface is. Okay, now if you look at this diagram, limiting friction means the maximum value of friction. Okay, maximum value of friction. Now what is this component? If this is F, this component is F cos 30. F cos 30. Okay, limiting friction is acting in this direction. Limiting friction is acting in this direction. Normal reaction is acting upwards, or reaction force is acting upwards. Now, limiting friction, maximum value of static friction is equal to mu s into reaction force. Okay, what is reaction force here? We will calculate. One force mg is acting downwards. Mg is acting downwards. And one more thing what is happening is, here for this R, there is one vertical component of force. This is vertical component of F. If this is F cos 30, then this will be F sin 30, because that is the opposite side. This will be F sin 30. Okay. Now what we can write? F sin 30 plus R will give you mg, or reaction force R equal to mg minus F sin 30. mg minus F sin 30. Okay. So therefore, if you substitute in this equation, what happens? Limiting friction is equal to mu s into R means mg minus F sin 30. Sin 30 means what? Sin 30 is half. So it is F by 2. F by 2. So this is mu s. So limiting friction is equal to mu s into mg minus F by 2. Third option is correct. Okay, here we should be very careful, since the applied force is making some angle here. Okay, now this force has to be resolved into one horizontal component and one vertical component. This horizontal component is responsible for production of frictional force. Okay, and meanwhile what is happening is, that vertical component of force is being added up with the reaction force. So upward forces should be equal to downward force. So F sin theta plus R should be equal to mg. Okay. Next question. Question number 59. The coefficient of friction of a surface is 1.71. The angle of inclination so that the body placed on the surface just begins to slide down is, we know this condition. The body placed on inclined surface just begins to slide. We call it as angle of repose. Okay. At angle of repose, mu s is equal to tan theta. At angle of repose, mu s is equal to tan theta. So therefore, mu s is given 1.71 is equal to tan theta, or theta is equal to tan inverse of 1.71. So we know that tan 45 is equal to 1, tan 30 is 1 by root 3, tan 90 is infinity. So therefore, so answer should be equal to tan 60 degree. Okay, because tan 60 degree is root 3. Root 3 is approximately 1.7. So therefore, third option is correct. Next, last question. A body of mass m is placed on a floor of a lift. If the lift falls freely, okay, so there is a lift, body of mass m is placed here. Okay, now lift falls freely means this mass experiences weightlessness, means its effective weight is 0, or the reaction force between the floor of the lift and the mass is 0. So therefore what happens? Frictional force is equal to mu s into reaction force. If the reaction force is 0, frictional force becomes 0. Okay, if the frictional force becomes 0, okay, then what happens? Then the frictional force offered by the body will become equal to 0. That means it becomes very easy for someone to pull this mass away. Okay, because there is no friction. If friction has to be there, what has to be there? Reaction force has to be there. Now since the lift is under free fall, reaction force is 0, so therefore frictional force is 0. So therefore fourth option is correct.